Hi everybody, so we're going to continue with our respiratory system lecture. This part of the lecture is going to be focusing on transport of oxygen through your body. So we're going to start by looking at the best mechanism to transport oxygen. We learn about that to be the hemoglobin, and hemoglobin carries 4 oxygen at a given time if it's fully saturated. Now when hemoglobin is bound to oxygen, we refer to this as oxyhemoglobin. Something interesting about that is that when you are when your hemoglobin binds to the first oxygen, then the second one binds much easier, then the third one, and then the last one binds real easy compared to the other 3. Now, when oxygen is required by your tissue and it needs to be dropped off, you can, as soon as you drop the first oxygen in your hemoglobin, the second one gets released much easier, and so forth, so on and so forth. So the third one is easier, etc., etc. So by removing one of the oxygens, you basically enhance the removal of other oxygens from hemoglobin. Now, when oxygen is being lost from hemoglobin, we use the word D. D implies a lack of. So deoxy means a lack of oxygen. So hemoglobin that has lost its oxygen is known as deoxyhemoglobin. Now, for us to understand how oxygen gets either picked up in your lungs or drop off in your tissue, we require an understanding of a curve or a graph referred to as oxygen hemoglobin dissociation curve. So I'm going to talk about this from the graph and kind of break down the graph for you. The information on this is present on the other slides, so you can review that, as well as the information that's present on the graph. So we're going to start with just looking at the numbers and what this graph stands for. So on the y-axis of the graph, you have percentage of saturation of oxygen for hemoglobin. So right here you have your hemoglobin with 0 oxygen bound. Here you have 1 oxygen bound, represented as red circle. So your saturation is about 25% because you have 1 out of 4. If you have 2 oxygen bound, that's about 50%. 3 puts you at about 75%. And if you have all 4 oxygen bound to your hemoglobin, that's referred to as 100% saturation. Now, if you guys remember from your external respiration, we also learned that the pressure of oxygen is going to be around 100 millimeter of mercury in your lungs. So, if you're thinking about your lungs, your goal is to pick up oxygen, not to drop off oxygen, right? So affinity of hemoglobin for oxygen in your lungs will be really high. Affinity implies that hemoglobin is going to hold on tightly to that oxygen. That implies high affinity. So if you notice where it says 100 millimeter of mercury here, if you go all the way to the top of graph and then send it to see what is the saturation of the oxygen, it's 100% saturation, which means that bulletin point right here, it's 100 millimeter of mercury, which is your lungs, and your oxygen would be almost 100% saturated. Now, if you guys remember also from internal respiration, we mentioned that your tissue will have a pressure of oxygen that's about 40 millimeter of mercury. So if I follow 40 millimeter of mercury in my graph, I notice that it hits somewhere over here, which is, if you look at the number, would be about 75%. Which means when your hemoglobin reaches your tissue, it decides, or its affinity for the oxygen will drop, and consequently you release the oxygen to the tissue, and that's what you want, right? You want to drop off oxygen to your tissue because your tissue wants that oxygen. Now let's continue with this scenario. Let's say you have a scenario where your normal, we have the normal here, again look at the numbers, you're at sea level and your pressure of oxygen is about 100, your saturation is about 98%, or we're just going to round it up to about 100%, okay? So you are fully saturated, basically. That's what I'm trying to tell you. You're fully saturated. So what happens if you go to high altitude when it comes to pressure of air as a whole? When you go up the altitude, the pressure of air is going to drop, and that also implies that the pressure of oxygen will also drop. So let's say at high altitude, your pressure of oxygen drops to about 80 millimeter of mercury at high pressure or high altitudes. Sorry, not high pressures, at high altitudes. But notice how the superior part of this graph is relatively flat. This means that even if I drop off the pressure of oxygen to certain numbers, I would still be able to fully saturate my hemoglobin. So right here, you're still about 95% saturated. Or I'll usually round it up to about 100%. So the goal is this. The purpose of your lungs is to pick up oxygen no matter how low the levels of oxygen is. If it's about 100, then your lungs is really happy. This is normal, so it saturates about 100. But even if you drop it off in your lung, drop off the oxygen pressure to about 80, it says it doesn't matter. I'm going to still hold on tightly to my oxygen because that's my goal. I want to pick up oxygen in my lungs. So even if the pressure of oxygen is low, I'm still going to suck that oxygen and I'm going to hold on tightly to it. So in another sense, here, these 2 points show a very high affinity for oxygen. Now, another scenario is when you are resting versus when you are exercising. So remember what we said earlier from the first graph I showed you. We said pressure inside the tissue, pressure of oxygen inside the tissue is 40, which puts you about 75% saturation, right? Which is this bulletin point right here. So when you're relaxing, your hemoglobin is about 75% saturated. Now, we have another scenario when you start to exercise. So when you start to exercise, you're going to start to use up oxygen, correct? So the oxygen level in your tissue drops from about 40 millimeter of mercury to about 20 millimeter of mercury. So in that scenario, do I want my hemoglobin to hold tightly to my oxygen? And the answer is no, because if my hemoglobin is holding tightly to my oxygen, my tissue will not receive its oxygen, and therefore it basically starves. So if the tissue needs the oxygen, I need to have low affinity for oxygen and be able to freely release that oxygen. So notice again, at 40, I'm about 75% saturated. But when I drop the oxygen level of the tissue to 20 millimeter of mercury, my saturation drops up to 40%. So I'm going to release a lot more oxygen if my pressure of oxygen in my tissue drops, which is again a scenario typical when you are exercising because your body needs that oxygen, so you are going to release it to your body. Now, some of the other factors that affect your hemoglobin affinity for the oxygen are listed here. So we talked about some of the concepts. When we talk about high hydrogen concentration, that typically means your blood is acidic or low pH. The actual number we're talking about is anything in humans is anything below 7.35. And low hydrogen means your blood is alkaline or basic, which means you have a high pH, which for our body implies higher than a pH higher than 7.45. Now, when you think about this, acidity, if you guys remember from our earlier lab, acidity also can be translated to high level of CO2, and alkalinity can be translated to low concentration of CO2, because CO2 is considered an acidic component. The more of it you have, the more acidic your blood becomes. And again, high metabolic or high activity of your body, changes such as infection or increase in body temperature are also going to be very similar to symptoms of having high CO2. Because this is how I want you guys to connect it. High metabolism, and you have high metabolism, means you're going to produce CO2 at the higher level, which means your blood is going to become acidic. So, when we're talking about, let's just stick to this. You have this graph that represents the middle line, represents the normal condition. So this is your normal condition. So notice how we say at 100% you have 100% saturation, about 100% saturation. And when you are at 75%, like when you're at 45, you're about 75% saturation right here. Okay, so this is your 75, the typical one we keep talking about. This is about 100% saturation. Now, when your blood is acidic, it means also implies that your CO2 level is high, right? CO2 is high. If your pressure of CO2 is high, that means your body is burning up oxygen and as a result producing high levels of CO2, and therefore it requires more oxygen to carry out the metabolism. So do I want to hold tightly to that oxygen if I have high concentration of or high pressure of carbon dioxide? The answer is no. I want to release the oxygen because I have too much of CO2. CO2 implies that your body metabolism is fast, and for your body to carry the metabolism, you need to release oxygen because oxygen is the fuel for metabolism. So let's take a look at this. This graph right here is an increase in carbon dioxide, which is also the same thing as having high concentration of hydrogen ion, which is the same thing as your pH being low. And you can put also that also means high metabolism. So at 40%, under normal condition, I'm about 75% saturated. But here at 40%, what's my saturation? About, I would say 65%, okay? Well, a little bit less than 65, but about 65% saturation versus 75% saturation. So if I have high carbon dioxide, high hydrogen concentration, which implies low pH, my body is going to release its oxygen. So hemoglobin affinity for oxygen is going to be low. Now reverse that. When your metabolism is slow, you will not be producing as much carbon dioxide, so the pressure of carbon dioxide will be relatively low. That means your hydrogen concentration also would be low, and it would be low, and your pH would be more alkaline, let's say above 7.45. In this example, they're giving you 7.6. So here, what I have is normal condition, right? And then alkaline condition in blue. Normal condition in the tissue, saturation is about 75% with 40 millimeter of mercury. But if any of the conditions that are mentioned above happen, then my body says, well, the pressure of carbon dioxide is already really low. So why do I want to release more oxygen to the tissue? It doesn't seem my body is using that oxygen anyway. So what I'm going to do is I'm going to hold on tightly to that oxygen. So under normal condition, saturation on the tissue would be about 75%. But under alkaline condition or low CO2, notice right here, your percentage saturation would be about 88%. which means you are holding tightly to that oxygen. You are having your hemoglobin has a really high affinity for oxygen. It's not going to let it go. So another thing which we also talked about already is associated with temperature and metabolism or having fever. Under normal condition, again, it's the 38 degree. This is your normal. If your metabolism is typically slows, you don't need as much as oxygen, so you're gonna really hold on to that oxygen. So let's say this is 10, 20, 30, and 40. Your saturation is about 75%, but at 40, at body temperature of 20, you're almost holding out completely to your oxygen. But let's say in scenarios where you're exercising or you have a fever, your body will require that oxygen. So you must have a low affinity for oxygen. So at 40%, your saturation drops up to about 55%. Hemoglobin easily releases the oxygen to your tissue so your tissue can carry out its metabolism or whatever task that it needs to complete. That's about it, and we'll finish this up with where we're done with your respiratory system.